much time. Okay, so what are the things that we need to look for today? First and foremost thing, you need to understand that we are talking about classification. Now when I say classification, okay, there are various things that you need to think of. First and foremost, you have decision tree, which you studied. Then you studied rule-based classifier. Now you are studying nearest neighbors algorithm. Okay, what is the purpose of this nearest neighbors, or where do you think the purpose of this nearest neighbors comes in? Now think, I have objects like this. Okay, there are certain objects like this that are placed, and you can see where they are placed. And then there are other certain objects also which are placed like this. Okay, they're placed like this. Now a new object is coming. What is a new object? A new object is coming, and it is coming right here. It is getting, where should I place this? Should I place it to these red dots, or should I place it into these blue dots? Or in general term, should I place this green data into this category or in this category? Where should I classify that? That is where the nearest neighbor comes into picture. Okay, you are going to do that based on certain values. Okay, certain algorithms. That is how you are going to figure out for that. Based on that value, you are going to place either in the red one or in the blue one. Okay, that is what it's been done. Very simple thing of knowing why you need nearest neighbors classifiers or not. Now what is the next part, or what is the things that are there in your k nearest neighbors? If you see mathematically, probably you will not understand what is it trying to say. But in very simple words, if you try to understand, it goes in a very simple way like this. First and foremost, or when I say step one, is to figure out what is your k. Okay, what is your k value? We are going to take two examples today, so you'll probably get to know. One example is obviously right from the net, and second example I'm going to write it and show it to you. Okay, each and everything. First, you are going to determine what is k value. The next thing is, once you determine step one, so that will be your step one. You are going to determine k. Now, generally, what is this k? K value generally or in practice, they take it in such a way that you are going to take an average of your data or average of your training set. Okay, that's a right word, average of your training set. Okay, that is what you're going to see generally. So if there are 10 training sets, we always take, or if there are 12 generally, you divide it by 2, you will be giving you 6. But generally, in very good practice saying is that you need to take an odd number of k. Just to avoid any sort of confusion, you're going to take odd number of k value. And it is generally an average of your the training data set, but it is not necessary it has to be like that. You can assume however you want. Based on your inputs only, it will vary. Okay, it has nothing to do. This is very much your assumption. Assuming k or figuring out your k is nothing but your assumption here. Okay, after you figure out k, step number 2 is to figure out your distance. Okay, how do you figure out the distance of it? Now to calculate distance, there are various types of names that you have, or various types of distance measures that you have. Okay, first one is obviously you would have seen it something yesterday also, called Euclidean. I think many people even in your school level also would have come across this Euclidean distance measure. Then there is something called Manhattan measure, right? Euclidean only we are going to use. What is Manhattan? Manhattan is a very famous street in New York. Okay, people who are used to seeing English movies, they would have seen this, a very famous street called Manhattan. How do you think Manhattan would be? Manhattan is basically a blocks of streets like this. In a very square way, they would have sort of put the streets like this. Okay, so if the data is like this in form of a square, how do you figure out the distance between that? You generally figure out like this, right? So if you want to figure out a distance part like this, okay, then what is the distance measure that is used? It is used Manhattan measure. You don't have to worry all these things and all. It is not there for the syllabus. I'm talking in general. Okay, there is one more thing also. Okay, called McLaurin. Okay, there is one more measure also called McLaurin. That also you don't have to worry. Our job here is to make sure that we know what is our Euclidean distance. Figuring out our Euclidean distance. If you know that, everything's pretty easy. Okay, next, that is your step 2. Then next one is step 3. What do you mean by step 3? Step 3, you are going to sort all of those in some sort of a order, generally in ascending order. Okay, you are going to sort of sort everything, what everything, the distance, everything in your ascending order. Okay, and then you are going to choose the top k. Why I'm saying top k? This k can be, if it is 5, you're going to choose the top 5 among where the ascending order. Okay, or top 3 based on the value of k. So that you are going to choose. Then later part is step 5 will be to choose the majority one. So you are going to choose the majority one. That's a next step or the last step of your k nearest neighbor algorithm. Okay, see this KNN, K nearest neighbor. You go study any of machine learning, you will be seeing KNN. Okay, all the NPTEL courses are now open. Okay, you have, if I'm not wrong, you have 3 courses under machine learning, you have 2 courses under data science. Why I'm suggesting these 2 courses is these 2 courses will be helping you in the 7th and 8th semester respectively without any problem. Okay, especially in terms of project, it will be really helping you, and of course it will add to your resume. Okay, you are supposed to go for placements from next semester, so it will really add value to your resume. Make sure that there are 3 ML courses and 2 data science courses. Please check in your NPTEL websites and do join. Okay, don't join for an easier courses. Okay, thinking okay I'll get this course done and all, maybe for a C or a C++ and all. You know that, okay, you already know that it will not be fun. Okay, it will not be fun. Even though you will be able to clear it, it will not be fun. You try to do this, and among these 5 at least try to clear any one with very good marks. Okay, something like this is way much better than the one you getting under a C or a C++, which you already know. Nothing much can be done about that. Okay, they're not going to teach anything extra also. Very few things only it will change, otherwise it will be remaining same. But ML and data science courses do join. Okay, so why what do you think I'm talking about? I'm talking about KNN. Okay, K nearest neighbors algorithm, KNN algorithm. So this is what the steps I wrote in very simple words. You see any of the places when it comes to algorithm, these sort of things will not be there. This is in general English I've written. Okay, but when you see it in the PPT, okay, in your notes, it will be in form of mathematical form only. And that only you have to write it in your exam also. Don't write it like this. This is for your understanding. Okay, so this is what we saw, and we saw yesterday one of the problem. What is our problem or an example we saw? We saw this example. See this example? I hope it's visible. Okay, see this? You have 1, 2, 3, 4. There are close to 12 data. Okay, 12 training sets you have. 11 are already filled up. 12th one is your Andrew. And what is it? You want to figure out whether or not this person is going to be a defaulter of loan or is going to repay his loans. Okay, see, I need to classify Andrew in either of whether he will be a defaulter of loan, which is with regard to yes. Here Y will be representing that he is going to be a defaulter of loan, which basically means he is not going to pay the loan. N will be representing no, which basically means no is not going to be a defaulter. He is going to repay his loans. But we don't know anything about Andrew. We know only about 2 values. What are 2 values? One is the age, other one is the loan factor. Okay, loan and age factor, only 2 things are known. Now, one thing that you got to keep in mind when it comes to KNN is, it is very good that you have numerical values. But there are certain places where you don't get a numerical values. So that will be our next example, right? So here we already have a numerical example. Now, if you have a numerical example, what is our thing that we need to figure out? First step, I told you very clearly, okay, that we are going to figure out our K. Let me go back to my screen. See this? What is my very first step? My very first step is to figure out my K. Okay, that's very first step. So how do I figure out my K? I'll go to my data. Where's the data? Data is right here. And what is the number of training sets you have? Okay, you have close to 12. If you leave out Andrew, you got 11. 11 divided by 2, 5.5. Okay, you're not going to take 6. I told you very clearly, it's always a good option to take an odd number of K. Okay, because it will give you a better analysis of what is going to happen under. Okay, why? Because see, at the last step you check. Where's the last step? See the last step you check. What is the last step you say? The last step says choose a majority one. So if I choose a even number of k, what is going to happen? If I get a value, value like this 3 3, how do you choose? It's not like we have a ICC Cricket World Cup happening where the scores are level and you're going to award England okay as a world champion just because they had higher number of fours. Okay, this is not going to happen like that. No such undemocratic things will be done here. We are going to do so to avoid all these sort of things, or you get a value which is 4 4. What is that 4 4 handle? You're going to see now. Okay. Now, if you choose like this, then you can't choose the majority one, right? Now, think about our own politics when it comes to India. Okay. We always majority means we always think of democracy. Democracy means our own Indian politics. Okay. Now, we have 542 seats. Okay. When it comes or 543, to be precise, where you have, when it comes to our Indian parliament. Any person who wants to form a government should have at least 272. Okay, that should be the magic number. Let's call it as a magic number. Now, what if all the people, okay, think there is only 542 like this? What if both the parties get 271, 271? Okay, whom do you choose as a, the person who's going to become a prime minister? Very tough. Okay, very tough. So what they have done, they have made it in a point that you need to have odd number of or a place where a person will not be having, or one person will be having at least one seat more than the other person. Okay, that is what the intention here is also. That you are going to have a k value which will be an odd number, which basically means you take 5. What will be the kind of, you can't have 2.5, 2.5. You will either have 2, 3, 2. That is in the worst cases. Or you can have 4, 1. Anything is fine. But this is only is needed for us, or this entire thing is only needed for us to figure out my majority aspect of it. Okay. Now that's very important for you to keep in mind because people will ask you. Okay, they will ask you when it comes to when you study now that when you tell other people that you have studied K and N, they will ask you what is this K. Okay, this K is used to choose my data, my nearest neighbors. Okay, be careful. K is used to choose my nearest neighbors, and in that I need to choose the majority one. Okay, so that is what we are going to see the point now. So I hope now you know why we are going to choose the odd number of ones. Okay, so you very clearly you get 5.5 as an average. We are going to take 5 as our k. Okay, first step is over. Yes. So first step, which is with regard to figuring out the k value, assumption of it is fully done. Next, I need to figure out my distance. See, for your thing, only things that is needed is with regard to Euclidean distance. Why Euclidean distance? Because it's a very simplest form of your distance. Okay, simplest form of your difference. And what is the the formula for this? The formula is very much like this: square root of x minus y the whole square. Of course, summation of it. Which basically means you're going to take what will be this x will be, see, they are taking whole square, which basically means that it will not be having any sort of negative value. Okay, what is this x? X is a person whom we want to sort of choose. So here in this case is nothing but your Andrew. Y is all other values. Okay, all other values that you're going to do. If this is only with regard to one attribute. What about the other attribute? Again here. What about the other attribute? Again here. Okay, that is what you are going to write when it comes to Euclidean distance. Okay, how you are going to figure out for this data? Let me sort of do that. Okay, so probably once you see this formula, you'll get to know what is that. So I need to figure out the distance for each and every training set, each and every training data. That's very important. Okay, so let me go here and check this. Okay, see, I need to figure out there are two numerical values only, so I don't have any issues with it. Two numerical values only, 25, 40,000. So I need to figure out for that only. So what I need to take? I need to take with regard to Andrew. What is first? I need to take with age, then with the loan amount. Okay, if I sort of do that. So first thing is with regard to age. Okay, so first what I'll do, I'll take with regard to age and then with regard to loan amount. Okay, with regard to age, what is the value you're going to get? Okay, I told you very clearly that it is square root of, okay, first one, what is the age of your Andrew? That Andrew age will remain constant. Okay, that will be remaining constant only. Okay, so I'll be taking the age of 48 minus 25. See, 48 minus 25 the whole square. Age is over. Then loan amount now. Okay. What is the loan amount you get? 142 and 40. So 142,000 minus 40,000 the whole square. What is the value you get? That value will be written across what? Across the first person. Who is the first person? John. So here you are going to write one more column and you are going to write it as distance. That value, okay, that value will be written here. This is with regard to what? This is with regard to John. Then the next person also needs to be done, Smith. Okay, so I need to figure out even for Smith. And I told you very clearly that to figure out your Euclidean distance, the first one, the Andrew person, the Andrew age will remain constant. Okay, minus, because that only you need to figure out. Okay, 48 minus who's Smith? Smith is 35. The whole square. Plus, who's the next person? The next person is 142 and 60 with regard to loan amount. So 142 will remain constant just like that, minus 60,000 the whole square. This is with regard to Smith. So what you are going to write? Towards one more column under Smith, you are going to write, or towards Smith, you are going to write what is the distance you got. That is what we do. Okay, like this, we are going to figure out for each and every person. Taking the value of your Andrew as common, the age and loan factor as common. We are going to take, sort of figure out for each and every person. So can I say very clearly that even the second, step is all fully done? Okay, I would have done all the distance and I would have written across my table. Okay, very simple. So let me go back to that and you will get to see what I am trying to talk about. Okay, so if I figure out that this is what I got. Okay, I hope it's not visible. See, this is what I got for each and every person. Of course, for Andrew, you're not going to do. You're not going to like do for Andrew 48 minus 40, then again 140. That's being plain stupid. Okay, for you other people, you need to figure out because you need to place Andrew in any one of the category, either yes or no. So you're not going to take that only. Okay, so if you do that, so you can see very clearly what is the Euclidean distance for each and every person. So you just saw here, right? So what is the value you get here? 102. What's the value? 102,000. This is what you get if you do sort of do this. And for this, how much you get? You get 82,000. Okay, so like this you got. So I figure out my Euclidean distance. Yes. What is the next thing I told you? Next thing I told you is please make sure that you are sorting all those things in ascending order. Okay, sorting all those things in ascending order. Based on what? How many I need to sort? First you sort it. Okay, then you choose the top k. I told you very clearly in this example, we have taken k as equal to 5. So we are going to choose the top 5. Okay, so you can see the thing that for Euclidean distance, which we have calculated for each and every values. Now, first step, calculate the Euclidean distance, square root of x1 minus y1 plus x2 minus y2. See, what is x here? Age and loan. Why we are taking age and loan? Because they are the numerical value. Based on that only you can say whether they default or not. You can't say it by the name aspect of it. No. Okay, just by the name, can you say whether a person is a defaulter or not? No. Okay, so we need to calculate the distance for all the data points. We have done it. Yes, we have done it. Okay, now what is the next thing? I told you very clearly. The next thing is you need to sort it and figure out the top k. In this case, top 5. Okay, so let me go and sort of do that. Okay, if I've done that, this is what I get. Okay, this is what I get. You can see very clearly the distance is all written. Then I need to say, figure it in ascending order. Either you can choose the entire table to be written in ascending order, which will take a long time, or you can just write the values like this: minimum Euclidean distance in ascending order. What is this 1, 2, 3 representing? They are representing ascending order. See, instead of writing like this, you can write it in ascending order. That is also a nice one. Okay, now you see 8,000. That's the first one. If you put it in ascending order, second one is 22. Third one is 42, fourth one is 47, fifth one is 62. Why I have chosen only 5? I told you very clearly, you choose the top k. What is the top k? Top 5. Okay, now that next important part. What is the next important part? See, I've chosen the top 5. Then I told you, you need to choose the majority one in this. A majority one based on the attributes or based on the decision what you're going to take. Okay, now based on this, you can see very clearly 62, 22, 47, 42, 8. Among this, you need to figure out whether is a defaulter or not based on the attributes. So 1, you can see 1 is y. So you got 1y. 2 is n. So 1 n. 3 is y. So you got 2 y's. 4 is again y. So you got 3 y's. Then 5 is no. Okay, so what happened? What happened is very simple. You got among the k is equal to 5, there are 2 default n. So n you got 2 and 3 y's yes you got. So defaulter you got yes in 3 times. Default no is equal to you got twice. 3, 2. Okay, 3, 2, which is having the majority one. Majority is y. What is that y? Yes, he is going to be a defaulter. So we can very clearly say Andrew default status is y. Is that the end? Yes. That's the end of your KNN. Did we do all the steps? Yes, we did all the steps. Okay, you can very clearly see we did all the steps. We first assume the k, we figure out the distance using our Euclidean distance. See, again, I'm saying some people will ask me why only Euclidean? Go for, Manhattan distance. You can choose any distance. Okay, Euclidean is the most simplest of form. Most simplest of form. Okay, if you go start studying data, so that's why I'm saying. Okay, see, I have this limitations of being under the purview of VTU and then doing it. But if you want anything extra, again, it depends on the time constraints. Okay, because we are not supposed to do more than 30 minutes or 35, 40 minutes class also. That constraint is also there for me. Okay, so keeping all these things, whatever that's possible, I'm trying to do. Okay, under VTU purview. And anything small things extra, I'm going to tell. Okay, but a larger perspective, why Euclidean, why not Manhattan? Okay, like that. If you go for another part, and why only 3, why only 5? Let's go for 7. If you go for 7, whether the data is changing, whether from this one, whether from the value of becoming a defaulter is becoming non-defaulter. If I take 7, if I take 9, what is going to happen? You can always do. Okay, you can always do, but why we choose the average of 5 here is the average will be giving you a better prospect. See, what you generally do, there are 53 people in your class. If I want to know the average of your class, do I calculate, or figure out for each and every one? No, I just take an average of your class. Then I say, based on this is the average percentage of your class. Okay, there may be exceptions. Okay, there may be exception in that if I choose only the top 30 people and I take an average, that average will be very different compared to doing it for 53 people. Okay, so the way of doing it may change. When you go into data science, that's what is the thing here. You play with data. Okay, you play with values. You see how things are changing with each and every data point. Okay, that is what you came across with regard to what is it? It is with regard to KNN algorithm. Very simple example. And you figured out that Andrew is a lone defaulter. Why? Because you got the majority count as what? You got the majority count as 3, 2. 3, 2 you got. 3 was yes, 2 was no. Because it's majority, you said yes. See, this is only I told you. If would have been if you have chosen K as 6 now, what would have been happened? Maybe think like that, for no, you would have got 3, 3. Then where do you put Andrew? Where do you put Andrew? You can't put any Andrew anywhere. You can't place this in between and all. That is going to be a defaulter and is not going to be a default. No. Okay. So only I told you that you're going to take an odd number of it. And because they were having 11 sort of data points, by 2 was equal to 5.5. What is the odd number that is nearer to 5.5? Obviously, it's not 7. Okay. It should be closer to your 5 only. That only I took. Now, just to make sure that you people don't really believe in this, I'm going to take one more example. Okay, one more example, and I'm going to take a very small value of K, because the next few slides will be based on dealing with those things only. Okay, when you take K value as this much, what is a property? When you take the K value as this much, what is going to be the property? That's the last part of your KNN. Okay, see, I'm going to put at least 2-3 examples in your PPT when I'm sending you. Okay, one of the example is already saw. 2-3 examples when I'm placing it in your PPT so that you get used to it. Generally, what is going to happen is they're going to ask you the algorithm. Okay, algorithm anyway, that whatever that is there in the textbook, I'll take the screenshot, I'll be placing it there. Okay, algorithm you need to write, and along with that they will say explain with an example. Then you will can take any one example. It's not necessary that you have to take 10 data points there, 10 training sets. You can choose even 5. 5 is fine, 6 is also fine. Don't choose anything less than that, because the table will look very small and it doesn't do any purpose. Okay, it doesn't serve the real purpose. Okay, so let me take one more example. Okay, this time I'll write it here. Okay, again, it's a very famous example. I've just modified few things there, here and there. So do stay back in the class. Okay, again, just because it's half an hour, all those nonsense you leave. First, try to learn things. Okay, now what's the next thing that you see here? I need to figure out my, again, I told you very clearly that I'm going to write name of a people. Okay, name of a people will be given to you. And then there'll be one more attribute, that one more training data that will be given to you, which is nothing but your age. Age is also given. Then there will be one more attribute that is given to you, which is nothing but your gender. Okay. Then the one more, the deciding attribute will be given to you. What is what deciding attribute? What sort of sport he plays, he or she will play. Okay. That is also given to you. Okay. Now, what is the problem? The problem is very simple. I'm going to write the names. Not all names. I'm going to just give it as A, B, C, D, E, F, G, H. How many? I, J. How many are there? Just look into this. I think it should be close to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Because I choose only 10. Okay. Don't really choose like this very big one. You can choose up to 5 or anything more than 5. Don't go less than 5 and all in exam. Okay. So I've chosen names as it's names only. Okay. Think of any names. A for, Alex, B for something, Bob. Okay. Like that. Then the age is given. What is the age is given? The age is given like this: 32, 40, 16, 34. 1 second, I'll write it very fast. 55, 40, 20, 15, 15, 15. Okay. So age is also given. Now the gender is also given. Now gender, be careful here. Be careful with the value I'm talking about. Gender is basically written like this. Okay. What are the two genders that you have? Only, of course, with due respect, I'm only going to take two genders here. Okay. F, F, again M, M. Okay. Then again you got F, M, F, M. Okay. This gender is also given. Now they have even given you what sport they are going to play. What is the chances they have given? They have given a chance where they are going to do two options along with the third option. Okay, what's the third option? First one is football. Okay, second one is neither, which basically means no, he is not going to play any of the sport. Neither means what is the meaning of it? That you are going to get only one more sport. That's all. Okay, he's not going to play any of the sport. Okay, then the next one is cricket. Other one is again cricket. Again, is neither. Again, cricket. Don't see my handwriting and all. Okay, because I need to complete this. That's very important. Okay, don't see the handwriting when you are writing it in exam. Please make sure that you are writing it in a very good way. Okay, it's football and then again football. Okay, I hope the order is all not proper, but again you get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, 10 values are there, not a problem. Okay, now you see I got these things. Now what is the purpose? The purpose basically comes here. I need to classify. Okay, I need to classify the person called. Okay, what is a person? X. There's this person X. What is his age? His age is only 5. Okay, and what is it? Is it a male or a female? Is basically a female. Oh, so she, person X, she's very small. She's only 5 years old. You need to say what sport she's going to play. How will you decide? Okay, how will you decide? That's very important. This is where K and N comes into alive. Okay, this is where it becomes very much alive. You can see very clearly. Okay, why it is coming up. Okay, why it is coming into picture now. You need to assign X, use a female, use a age of 5 into any one of these criteria. What criteria? What criteria you have? You have only 3 criteria, not more. You have either football to be put into, whether she will play football or she is going to play cricket or she is not going to play anything. Okay, neither. So these 3 categories only you need to put. Which one you will put? That's very important. Okay, for that only you need what is known as KNN. Okay, now what is the first step? We know very clearly that step 1 for us is to make sure that we figure out our K. How can you figure out K? See, if you there are 5 values here, sorry, 10 data points here, divided by 2, you get equal to 5. You can choose K is equal to 5 easily. Or if you don't want only 5, you can choose even 3 or 7. Or don't choose 1, that's being stupid. Don't choose 9 because you're taking almost very big data of K. Okay, so you have to go either between. So what's the midpoint? Midpoint is always the 5. 5 will be giving you a very good picture of what is going to happen under. So assumption of K, so that is done. We still not decided. We can either choose 5, 3, 7 like that, anything. Second step is to figure out our Euclidean distance. So if you figure out our Euclidean distance, how do you think it will be? I'll do it for 1. Okay, if I do it for 1, probably you'll get to know. Okay, so how do you think I need to figure out my, what are the 2 things that you have? You have the due distance with regard to age. Okay, but gender, how will you do? That's very important now. Okay, I told you very clearly that when you have a value which is something like gender, what is going to happen? Now, you can't put gender in form of a numerical value there. Is it possible? No, it's not possible. So what is the thing that you're going to do? What is the thing that you need to link off? There's a gender there, there's male and female. Okay, so your data needs to be discrete, numerical value. Okay, but what can we do for this? Very simple. You can assign what is known as a value to each one of it. Okay, and what is it? You can take male as equal to 0 and female as equal to 1. You can assign these 2 values like this so that they become integer values, and the same can be sort of implemented here. Because just by age you can't do it. When you have one more, see, if you had only age and you wanted to figure out what sort of sport she plays, you could have done that. But because you have one more attribute in terms of gender, you have to do like this. In the previous example, they themselves they are given the numerical attribute, the loan amount. Okay, here they have not given that, but you have to do it. So wherever you have male, you can take it as 0. Okay, wherever you got female, you can take it as 1. Or if you don't like that, you can take male as 1, female as 0. However, but don't take same. Take same, that's being stupid. Okay, that should not happen. You can either take 1 or 0 or 1, however you feel like. Like this you are going to take. So if I sort of figure out what is known as Euclidean distance, okay, for age and also for gender. Okay, so for age and gender, if I figure out the Euclidean distance, what is going to happen? The first value, what will be the first value? Okay, where do you think the values need to be written, or a Euclidean distance need to be written? Can I write entire thing right here itself? Okay, Euclidean distance. Don't see my handwriting again, I'm saying. Okay, so I can see the Euclidean distance can be written here. How? Very simple. First one, okay, can I figure out the first one? First thing is with regard to age. Okay, so how I'll do? You can do anything you want. See, 5 minus 32, 32 minus 5 whole square, both will be same values only. Kuch farak nahi padta, okay? Same values only you get. And you need to do the square of it. So you're going to get the same value only. You're not going to get any different value. Okay, so that you keep in mind that that, oh, y is only taking 5, then 32. What about 32? You can take. Okay, you can take, it will not be doing any sort of change to it. Okay, so can I do that? No, I'll write that. Okay, what's the value I'm going to figure out? First with regard to like this. Okay, 32 minus 5 the whole square plus what is the value? 0 minus, see, male is 0, female is, this is 1 the whole square. What is the value you get for it? The value is 32 minus 5, 27. 27 the whole square to 9, so 729. Okay, 729 plus 1 square, 1, which is equal to square root of 730. What is the value you get? 27.02. Okay, 27.02. That will be the Euclidean distance of your this person, which is with regard to this one. Like this, you need to figure out for each and everything. If I do for the next one, what is going to happen? I'll write here itself. Okay, I'll write it here itself. So if I figure out for the next one, what is going to happen? Let me go here. So what is the next thing that you got? 40 minus 5 the whole square, the age I'm talking about, plus the gender, 0 minus 1 the whole square. 35 whole square plus 1 whole square. What is the value you get? Okay, square root of everything if you do, you get the value as 35. Almost 35. Why? Very simple. 35 whole square. Okay, because 1 is very small number. Okay, very small number. In fact, you get 35.01 and all. Okay, so this one is almost square root of 35 whole square, which is nothing but 35 only. So you get the value like this, 35.01. Okay, like this you need to figure out for each and every value. Okay, so I've already done that, so I'll write these values very fast. Okay, so I'll just write it this 35.01. So what's the next value? You got 11. Next is 9. Next is 50. Next is 35. Okay, next is 15. Anyway, it will be there in the PPT. Okay, you can easily sort of figure out. Okay, what is this and all. See, this is what the values you get, the Euclidean distance. So the third step or the second step, figuring out my Euclidean distance, is also over. Okay, what's my next step? My next step is to make sure that I figure out what is known as the ascending order values. Okay, ascending order values. What are my ascending order? First, among all these things, if I put into place, what are the values that I get? I get this as my first value. 9, smallest. Okay, what is my next value? 10. Where is 10? 10 is very much here. This is my second value. This is very much my third value. Okay, see, for k is equal to 3, think about it. If I take k is equal to 3, 1, 2, 3, I already got my top 3. Okay, I already got my top 3. And what is this 9? 9 is basically representing the cricket. Okay, what is 10? 10 is again representing your cricket. Third one is playing what? Football. If you take 3, you have 2-1 combination. 2-1 combination that this girl X is going to play cricket. Very simple. Okay, very simple that you are going to play that as cricket. But if I take k is equal to 5, let me check. Okay, let me check with regard to k is equal to 5 and figure out okay what is going to happen. K is equal to 5 matlab after 10.5. 1 second. Yeah, after 10.05, what is my next smallest number? 11. This is 4. And what is the play with regard to 11? Cricket. Oh, already got cricket only, so no problem. So even if you try to do 5 also, it will be cricket only. See, already you got, see, it's like 5 one days, 4 one days are over, 3 one days, India has won. See, 1 day, only England has won. So obviously, see, this is 1. So we'll figure out that also. After 11, what's the next value to me? 15. Okay, this is my fifth value. And what is 15 playing? 15 is playing neither. So I wanted to show this one, very important. Okay, 15 is playing neither. So what is the count you got at last? You got 3 cricket. Okay, and what is the next thing? 1 football, and 1 is not, she is not going to play anything, neither. So when you have values like this, okay, 1 second. Yeah, if you have values like this, what is the problem that you have here? The problem is very simple. You don't have to worry about anything. You can directly say that X is going to play, very sure that she is going to play cricket. I don't know what she is going to play once she grows up because she's only 5 years, but I can easily classify X under the criteria called cricket based on my KNN algorithm. I can easily do that without any problem. Like this, where what is the value I took? I took even for 3, it came up to cricket only. I took only for 5, it came up to cricket only. You check with regard to k is equal to 7 also. Okay, k is equal to 7 means what is going to happen? The next smaller number you need to take. Okay, what was the smaller number? 15. After 15, what is the smaller number I have? This 50, 35. Okay, this one. This will be my next smaller number, which is with regard to 6. And that is with regard to football. Okay, then the next one I need to do 7. Don't take 9 and all. There are only 10 records. If you take up to 9, then you're taking a very big value of k, which is not recognizable, which is not a good practice. You should always have very much closer to your average. Even then, I'm taking 7 just to show you how things may change. 7 should also be not chosen. 3 should also be not chosen in an ideal condition. You should always go with an average value, which is up to 5. Okay, so 7, where's the next one? What's the next value of 7? 35. See this one, not 35.01. Very, very rarely you get 37 like this, 35 like this. And what is that? 35 is again cricket. So what is the count that you get it for with regard to 7 values? You get 4 year, 2 year, 1 year. Here also you can see very clearly it's basically cricket. Okay, this is the beauty of KNN algorithm. When you go to lab in 7th semester, KNN, you're going to take a data set. Okay, you're going to write an algorithm in